VLPSos here. This is a video lesson for Python programming, managing instances. I recommend pausing on occasion to practice. We're going to import random and use the random module later on. Instances are members of a class. It is helpful in programming to think of things as objects that have attributes, even if the objects are something that we could not touch. If we're programming a game that had adventurers, monsters, rooms, and treasures, we could go about coding for such a game by defining each of those things as a class, choose the attributes that would describe those things, and then go about making several instances of each. Think of the popular game Minecraft. Its programming is sophisticated, or is it? Think of the game as having a class called block. The attributes of a block are numerous, but include things similar to XYZ location, chunk number, name, texture list. Once what it means to be a block is written, we go about making instances of block. Many instances, many similar but none identical. Then write a class for player, a class for mobs, some methods for how things interact, make instances of those, and you're done, right? Yeah, that is how it's done. So how do we manage a whole bunch of instances? We are going to write a class as an example of managing many instances. We're going to make many instances of the class that we're going to write called egg. And inside the egg class, we're going to define the init function for this class. And we will require color to be sent to the init function when we make an egg. An egg will have an attribute called age, an attribute called color, whose value comes through the argument, and an attribute called rotten, which will be assigned to be false when the egg is created. And we can make eggs the slow way. Well, the way we've learned, but it'll be the slow way once we learn a faster way to make eggs. We could call an egg egg_1, which is a variable that will be assigned to be a call to the class egg, and we need to send it a color when the egg is created. So here we've created one instance of our class egg. And of course, one of the advantages of using classes is that we can make several instances very easily. I can make another egg that is brown called egg2, and we'll make a third. The color of this third egg, once I get the parentheses in the right space, will be white. Quite a slow way because it required that much typing to create 3 eggs. We could save and run and notice that, of course, nothing got printed out. We just created those instances and they're stored in memory. That was slow. How would we manage our eggs? We have 3 of them. If we're going to iterate through our eggs or our collection, then it would be a good idea to put them in a list. We're going to make a list called carton and put our 3 eggs into it. We put the variables into it because the variables stand for the instance. We can access all of the attributes and their values through the variable that has the instance assigned to it. And if we have a carton, a list, we can now iterate through our list and modify an attribute we're going to modify the attribute age by adding 1 to it. Our eggs have gotten older. We access the age attribute by first calling the instance. The instance is item. Item is the iterating variable. So as we iterate through the carton, we get each egg and call it item and access age and add to the age. We can see if that was successful by printing not all of our eggs, but we can check 1. And we're going to refer to egg 2's age by egg2.age. Save and run this. An aged egg, we see the age of the egg 2 is printed as 1, so this must have worked to change the attribute since the age attribute was set to 0 when the egg was created. Egg 2 was created in this line. Moving on, but what if we wanted to make 100 eggs quickly? Well, bring in the dictionary. We are going to redefine our carton, the place where we will store instances, as an empty dictionary. Notice the squiggly brackets. Nothing in it yet. First, let's put some eggs we made into the dictionary. Remember, a dictionary needs a key, which must be unique, no duplicate keys, and a value, which will be the egg. So we are going to add to the carton, with key 1, the egg that we already made called egg_1. I can save some time by copying, changing these keys so that they're unique, so that egg 2 and egg 3 is now inside of our carton. And we can see them. Now that we have a dictionary, we can iterate through the dictionary with a for loop. The iterating variable will be key because it describes how we're using the iterating variable. We're iterating through the carton, and we are going to print in the carton, the dictionary, the egg with the current value of our iterating variable key. What we get when we see this for loop that iterates through the carton, which is now a dictionary, is literally what Python considers to be the instance if we just print the instance. And we can see that it is an egg object, and this number is a memory address where that information is stored. We didn't get something very satisfying, but what we saw was what an instance looks like, not the attributes of the instance. We'll do this again. We'll iterate through the carton. But this time we're going to print the attributes of an egg. And we'll put it into a sentence. We're going to list 2 attributes. So we refer to the dictionary that it's stored in, the current egg with the key with our iterating variable, and the color first. And then in the same dictionary, with the current value of our iterating variable key, the age attribute. Saving and running, we see something that we can relate to much more easily than the object and memory addresses of our instances. We can see that we have 2 brown eggs and 1 white in our carton, and they all have the same age of 1. Much nicer. Now, how about laying a load of eggs? We wanted to make a whole bunch of instances. Now that we have a dictionary with the 3 eggs that we created in them, let's create many, many more. To do that, we're going to assign a variable called new key and start that with the value 4. 4 because we already used the keys 1, 2, and 3. So the next key for the next egg that gets created would naturally be 4. And we assign this to a variable because we're going to increment the new key every time we use it. We're going to add 1 to it so that it becomes a new number that can be a new key for a new egg. Creating eggs will be done with a for loop. We'll have count, and we'll create a range. We'll go from 0 to 100. Every time we iterate, we're going to create an egg. So if we iterate 100 times, then we're going to create 100 eggs. Every time we create an egg, we're going to choose a color at random from a list of colors that will include white, and it'll include white twice, brown, it'll include brown 3 times, and then green only once. So if we choose from this list, we have an unequal probability of getting a certain color. Brown would be the most common, chosen 3 out of 6 times. Then we make our egg. We do that by referring to the dictionary where we're storing them. Our new egg will need a new key, which will use the current value of new key, and it's equal to a call to the egg class with the color that just got chosen at random. That creates a new egg. But if we were to run this line of code again, if it was reiterating in the for loop and we ran this line of code, if we did not change the value of new key, we would create a new egg with the same key, which would have the effect of overriding the egg that was just created. So if we want truly a new egg afterwards, we have to create a new key by adding 1 to the key that we just used. So the first time this code block runs, the new egg will have a key value of 4. And then the value of new key will go up to 5. So by the time we iterate again and get back to this, the key will be 5, then 6, then 7, and truly create new eggs in our carton. We're going to save. We can run right now, but we don't see evidence of all those eggs that got created. So we'll have to look for them. But first, a note about what we just did. We made a new egg by calling the class and sending it a color that the double underscore init double underscore special method expected. The instance was assigned to be the value within the dict carton with a key equal to the value of new key. We had to increment new key integer so the next time it was used it would be a unique value. Now let's age our eggs and view them. With the for loop for key and carton, in the carton, with the current value of key, attribute age will be reassigned to be itself plus 1. And we will print and borrow the same print line here and put it in our iteration. Let's take a look. We have a whole list of eggs. And their colors have been chosen at random. Many are brown, many are white, and there is occasionally a green egg. Also notice that the 3 original eggs were aged twice now in our code, so they have a different age value of 2. Let's do something a little more sophisticated with our egg carton. This has been previously coded. I'll uncomment it and describe what's happening. Let's age them and count their color. So we've assigned variables white, brown, and green to be an initial value of 0. We then iterate through the carton again, and we age them again. Then we take a look at their color in a decision structure. If the color is white, then we add 1 to the white variable. If the color is brown, we add 1 to brown, otherwise add 1 to green. So as this iterates, it ages and checks the color of our eggs and then increments these 3 variables. It counts the number of colored eggs that we have, and then it reports how many in a print line we counted by printing the values of white, brown, and green. So we can run this, and it should be different every time. We can verify that in this execution of the program, we had 48 out of 103 eggs brown, and then about a sixth of them green. So it's working as expected statistically. And if we run it again, these numbers are going to be different. We have an egg counter. So what does the carton dictionary look like? We can print the thing. Very straightforward. And run. We have a different count of eggs, and in my version of IDLE with my interface, it says that it's squeezed 83 lines of text together and it's not displaying it. So it doesn't display automatically in this version of IDLE with my operating system, but if I click, right-click and then view, I can see the dictionary printed in one line in a separate window, and if we take a look at it, it is a very long single line. It has keys and values, over 100 of them, and each key is one of the keys up to 103, and the value is an instance of egg recognized as an egg object with a memory address. Not very exciting, but that's what the dictionary looks like if you just printed it. This introduction to managing instances comes down to this. Use dictionaries. And let's provide another example of another class and creating them using a dictionary and managing them. I'll uncomment this class and describe the code and then see it run. A class called player has been defined. There is an init function inside of it that will be called when we make an instance of player. The attributes of player are active, name, skill, and items. It's a Boolean value, 2 variables that come through in the argument, and an empty list. We then create a dictionary that's empty called players. And we create 3 players by using the name of the dictionary with a unique key that is a string, calling the class player, and sending to the init function what it expects. The 2 values, the first of which will be named, will be name, and the second string will be skill. Remember that self is represented in the init function, but we don't send self in the argument when we call the class, because self is automatically sent as a behind-the-scenes record of that particular instance that's being created. So self represents the unique instance that's being created by player, but is not something that the coder has to send. It's done automatically. We have to send the remaining variables, name and skill. 3 players have been created, Biff, Buffy, and Clive, and they have 3 skills: overconfidence, underestimated, and math mystical. We then iterate through our players dictionary. And every time we iterate, we roll at random from 1 to 100. We define a list of rewards, and then we check the roll. If it's greater than 30, which approximately 70% of the time it will be, then a reward is chosen at random from the list, and the player's attribute items, which is an empty list to start, is appended with the reward that got chosen. Now, if we didn't make that roll, then the player's Boolean active attribute, the attribute called active, which is a Boolean value, gets reassigned to be false. In other words, every player gets a chance to get a reward or become inactive. And then when that for loop is done, we iterate again with an iterating variable called IV. And if the Boolean, the active attribute Boolean is equal to true, meaning if the player is still active, then there's a print that prints the name and the skill. And if the player's items list, which is an attribute, is not equal to 0, meaning if the player gained an item, then it will print with A and it will list the contents of the item. Let's see this run. After all of our eggs were processed, we get to reporting on our players, and we see the evidence that Biff the overconfident is up with a hearty stew. So Biff remained active and received hearty stew as a reward. Clive the math mystical is up with a chunk of metal. So Clive was still inactive with a reward. We would assume then that Buffy did not make her reward roll. Let's see this run again. There's our eggs. This time, Biff, Buffy, and Clive made their roll, and they made a chunk of metal and a hearty stew and a compliment, respectively. This is another example of player and another way that a dictionary is being used to store and manage the instances. In this example, there weren't a whole lot of players made. We only made 3. Now you. You have seen how to create and manage many instances of a class using a dictionary. Write your own simple class and practice making over 100 instances of it using a dictionary and the method of incrementing an integer to use as a key. So the method of incrementing an integer to use as a key was shown when we made our eggs. It was the new key that we started with, and then after using that new key, when we created an instance, we increased it. We incremented it by 1 so that the value could be used again as a unique value. That's what we mean by incrementing an integer to use as a key. Have fun.